When solving worded equations, you are inherently going to find that you'll be answering a question about what the period is, what the turning points are. Sometimes, I guess, might possibly finding x-intercepts and sketching the graph. There'll inevitably be one part of the question where you'll need to solve for a particular value. And remember, if you cannot generate an exact value, then I'm afraid we can't do much about it. We have to use the calculator. It is suggested that the height, ht meters, of the tide above mean sea level during a particular day at sea break is given approximately by the rule ht equals 5 sine pi over 6t, where t is the number of hours after midnight. So there is our equation. We're going to have to deal with this at some point. So there's the equation. We see it's hours after midnight. This will possibly be important because you might get a question that says, what's the tide at, I don't know, 3 p.m. And you'll have to know that 3 p.m. would be where t is 15, because that's 15 hours after midnight. We have to draw a graph of y equals ht for 0x to 24. So this is where we need to go and set up our things such as our period, our amplitude, see if it's reflected or not, and see what we need to do. So let's go with the amplitude. So the amplitude here is 5. It's a sine graph, so therefore the period is 2 pi over n. So 2 pi over 6. So 2 pi divided by pi over 6 is equal to 2 pi over 1 times by 6 over pi. So here we go. Our period is 12. So that means the pattern starts and ends at 12. So if I was to draw a very rough sketch of this, there's my period of 12. And we can break it up into quarters, which will be 3, 6, and 9. It's not an upside down sine graph, so it's going, but it is an amplitude of 5. So this is the shape of the graph. It hasn't been moved up anywhere, which is wonderful. So we can, and this is 5, and that's negative 5. So we're going to go 1, 2, 3, 4, 5, 6, 7. Oh, my sine graph melted in the sun there. There we go. That's a very rough approximate sine graph. We can put in our turning points here. 9, negative 5. This is 21, negative 5. I just want to double check what is this modeling? Oh, above mean sea level. So the horizontal is the average sea level. So if you see mean sea level, it's not talking about the waters were angry that day. No, this is the mean sea level, means that it's the average. So it seems to be cyclic. There are some times where the tide is above the average and sometimes the tide is below the average. That's what it's suggesting here at a particular time. When was high tide? Well, again, this is classic. As soon as you start seeing things like this is a classic maximum. And when is solve for t. So we know that's 3 hours after midnight and 15 hours after midnight. Now, this is where students like to flip a table over because they'll write an answer and they think it's correct. When it says when, assume that's a time. So assume that's saying like it's in AM or PM and that kind of thing. Or if you are a military type mind, you could say 1500 hours or 300 hours, whatever the case might be. But don't write 3 and 15 because that's not telling me when, that's just telling me t values. So this is one of those things that we know you know the answer, but you've got to write it as the question has asked you for it. So this would be at 3 a.m. 3 p.m. What was the height of the high tide? Well, the height of the high tide would be the amplitude's height, and there's no vertical translation, rather, thankfully, so we don't need to worry about that. Is it all in meters? It is in meters, yes. So we can actually say here, it's at 5 meters with the height of the high tide. D, what was the height of the tide at 2 a.m.? So this is where we'll need to substitute T for whatever 2 a.m. is equal to. And of course, 2 a.m. is 2 hours after midnight, so it is 2. So this will become h of 2 is equal to 5 times sine pi over 6 times 2, which if we cancel that down, we go to 5 times sine. Those can simplify. That becomes pi over 3. And then if I've forgotten what that is, I can draw my little exact values triangle, or at least half of it anyway, the relevant part. And I can remember what pi over 3. So sine is opposite over hypotenuse, so root 3 over 2. Now the textbook, if you go and do questions like this, may have it in decimals. However, as a good maths method student, if you can get an exact value, you will do an exact value. 2 a.m. is there, so we actually can now just, for completion's sake, we can actually now label that coordinate. Now, there is a reason why I wanted to put that on the graph, is because I had a sneak peek at what was the next question. The next question says, what was the height of the tide at 2 p.m.? Now, as you know, that's 14 hours after midnight, and you would do the same procedure, except now that I've got a graph, just realized 14 hours is exactly the same spot as 2 hours. Funny enough, it's because it's a period later. The period here was 12, so we actually don't need to do any working out whatsoever. I can just write 5 root 3 over 2 meters. A boat can only cross the harbour bar when the tide is at least 2.5 meters above mean sea level. When could the boat cross the harbour bay on this day? From a picture point of view, if that's 5, 2.5 would be about here. And what the question is asking is to say, all right, if the boat can only be on the water at times above that red dotted line that I've drawn, what times are those? So we'll need to solve for the ht equals 2.5, so we'll need to solve for t. Now we have to make sure to be careful to see whether or not this will get an exact value. If it doesn't get us an exact value, then we'll have to use the calculator. We can change that. 2.5 is 5 over 2. Can divide both sides by 5. And wouldn't you know it, sine pi on 6t is equal to 1/2. 1/2 is an exact value. So we can solve it accordingly. So first and foremost, we have it's positive. And we know that sine is positive in the first and second quadrants. The reference angle. So the reference angle here, so sine of what gets me 1/2? Well, opposite over hypotenuse. Sine is opposite over hypotenuse, so it's going to be pi on 6. Then the domain, So we know that t is between 0 and 24. That's what the function has suggested. Therefore, pi on 6t is somewhere between 0, because we did 0 times pi on 6, 24 times pi on 6. So that's going to be 24 pi divided by 6. So that's going to be 4 pi. Pi on 6t, well, is equal to. Now I like to still draw my little pictures because I have a terrible memory. So there's 0, pi on 2, pi, 3 pi on 2, 2 pi, and then we go around the circle again, 2 pi, 5 pi on 2, 3 pi, and 3 pi on 2. So there's one value here, one value there. There's another value here, another value there. So we want the first one, which is 0 plus pi on 6. 0 plus pi on 6. Then we want the next one, so that's this one sorted. Then the next one along will be pi minus pi on 6. So that's that one sorted. The next value will be 2 pi plus pi on 6. So that's that one sorted. And then this one, last one, will be 3 pi minus pi on 6. So we can do that arithmetic, so that'll be equal to pi on 6. If I've got a pi, take away 1/6 of a pi, that's 5/6 of a pi. Got 2 pi's and I add 1/6 of a pi. Well, 2 pi is the same as saying 12 pi on 6. So that's going to be 13 pi on 6. And then we've got 3 pi, take away a pi on 6. So 3 pi is 18 pi on 6. Take away a pi on 6 will be 17 pi on 6. And then all we need to do is divide everything by pi on 6. And so t is equal to, so pi on 6 divided by pi on 6 is 1. 5 pi on 6 divided by pi on 6 is 5. 13, 17. So now we found the t values. Let's go and check the questions here. Does it say when could? So that means that is 1 to 5 p.m. and then between, 5 a.m. I should say, and between 1 p.m. and 5 p.m. in the afternoon. So my answer is the boat can cross the harbour bar between 1 a.m. and 5 a.m., 1 p.m. and 5 p.m.